This session is all about how to draw great graphs. As you'll see, it's also about not losing marks. The first thing to decide is what type of graph to plot. Is it a line graph or a bar chart? Well, this will depend on your data. Let's look at some examples. Okay, so why is this drawn as a bar chart? The answer is because some of the data are categoric. In this case, the material. Categoric data have labels. For example, materials, colours, countries, etc. A good way to check is to see if there could be a valley between the points. Here, halfway between concrete and copper, for example, makes no sense at all. So, the data are categoric. Okay, so why is this one drawn as a line graph? Answer: because both sets of data are continuous. Continuous data are numerical. Examples of continuous data include time, temperature, etc. Again, if we try the halfway test, for example, does halfway between 4 newtons and 6 newtons mean anything? Yes, it would be 5 newtons, so the data are continuous. Okay, so we know what type of graph to plot, but how do we set out the information? Okay, so which variable goes where? The general rule is independent on the x-axis, dependent on the y-axis. But there are occasions when you don't follow this rule, but the question will always tell you if this is the case. Here are some examples. Okay, so the next question is how to choose a scale for your axes. A good choice will make it much easier to plot. So, look at the range of data. Aim to fill as much of the paper as possible. But choose a scale that's easy to plot. For example, go up in 5s or 10s, depending on the data. If you choose to go up in 7s, for example, you will find it much harder to plot. Your axes need to be labelled with quantities as well as units. For example, time in seconds. Mass in kilograms. Temperature in degrees C. Force in newtons. Or velocity in meters per second. Otherwise, it's meaningless. There are some common sense rules too. Always use a pencil. Common sense, really. Yes, always bring a pencil so that you can correct any mistakes. If you haven't got a pencil, borrow one, or better still, just get organized. And the second common sense rule is make sure the points are plotted in the right place. Yes, it's obvious, but it takes seconds to double check, doesn't it? And it's a great way to lose marks if you don't. Often, you'll be asked to plot a line of best fit through your data. Drawing a line of best fit has a few basic rules. This is not a dot-to-dot exercise, so don't do it. Draw a smooth line that passes through as many points as possible instead. The line may not go through all the points, but that's okay. If any of the points are anomalous, just put a ring round them and ignore them. You do remember what an anomaly is, don't you? Test yourself. That's right. It's a point that doesn't fit the pattern. But you already knew that, didn't you? Lines of best fit may be straight lines. Before you draw your line, circle any anomalies. In this case, always use a ruler. In science, lines of best fit can also be curves. But don't worry, just draw a smooth freehand line through the points. It may help to turn the paper round as you do this. As before, circle any anomalies. One single pencil line is what's needed. Please don't go over and over and over the line with your pencil. It just looks terrible. And definitely no dot to dots, please.